Good morning, sir. My name is G. Kiran Kumar. My roll number is 219518047. I am from EC section B, and the topic is Bluetooth mesh analysis issues and challenges. Introduction. Nowadays, there are many wireless communication technologies that can be used for the development of IoT applications in domestic, urban, and industrial scenarios. Prominent examples are Zigbee, Z-Wave, Thread, 6-low weapon, Wi-Fi, Bluetooth low energy, Bluetooth low energy also known as BLE. These technologies are extremely heterogeneous in terms of protocols, performance, readability, latency, cost, and coverage. Abstract BLE Bluetooth Low Energy is a widely used short-range technology which has gained a relevant position inside the Internet of Things. It is also known as IoT. We very well know that. Paradesign development thanks to simplicity, low power consumption, low cost and ubiquitous. New enhancements over BLE have focused on supporting mesh network topology compared to other mesh. Low power consumption, low cost and robustness networks. PLE mesh has only considered a managed flooding protocol in first version. Managed flooding may generally seem infrequent in many contexts, but it is a high desirable option when data transmission is urgent. The network is small, so its configuration changes in a very dynamic way. Knowing the interest to many application contexts, this paper analyzes the impact of tweaking several features over the reliability and efficiency of the mesh network in order to estimate the real performance of a mesh network development. This paper evaluates the effects of the interaction of chosen parameters, their appropriate adjustment in relation with the characteristics of real implementations and the true overhead related to the whole protocol stack. Index type Bluetooth low energy, wireless mesh networks, BLE mesh, managed flooding performance. Overview of Bluetooth mesh, basic basis and its architecture. In this session, we will introduce key aspects that characterize Bluetooth mesh. Understanding BLE Bluetooth low energy mesh network first requires to define the terminology present in this diagram related with the BLE mesh concept and topology and the required features to support them. And research of the mesh network including the main terms and concepts that will be around the paper as shown figure 1. Here we can see the flowchart or a given picture. PLE mesh node types and topologies. Bluetooth mesh PDU transport basics. Good throughput estimation requires to take into account real packet overhead input to the whole protocol stack specification and time overhead associated to delivery process across the network. On the other hand, the reliability of network is based on reputation of messages. The reputation may be controlled by several redundant processes managed by different parameters. In addition, BLE mesh supports transmission of acknowledged and acknowledged messages. First one, protocol stack overhead estimated data. It is a transmitted sequence using at least one of the three advertising channels while data transport capacity is limited by the advertising packet size and overhead introduced by the old protocol stack from the barrier to access layer. Although messages are usually short enough to be transported in only one ADB frame, PDU segmentation could be also required. In any case, we will see that a low percentage of ADV PDU contains relevant data. Here we can see the use of BLE advertisement to send mesh messages. Here we can see that address, access address, advertising physical channels, PDU 8 to 39 bytes, and the access address is 4 bytes, and CRC is 3 bytes, and ADV data is 0 to 31 bytes, and ADV address is 6 bytes, length 1 byte, type 1 byte, and version is 5.x, and another version is 4.x. And here AD data network PDU is 1 to 29 bytes. Here we can see that channel 37, 38, 39 is okay. Let us see some of issues and implementations. Depending on selected configuration and firmware implementations, our issues could affect the performance of a Bluetooth mesh network. We will analyze some of them next. First one, blind times. Real Bluetooth devices present non-idealization in their operation that needs to be considered when performance is estimated, although we cannot act modify them. From the point of view of all over network, performance may be the most important impairments or one of the effect to the scanning produced of the Bluetooth devices, especially in a Bluetooth mesh network. What are the specifications state that the relays or front nodes should be scanning as close to 100% of the time as possible. In spite of this, as we stated before, due to five-frame implementations has hardware limitations during some time, the scanners eventually leave the state and any packet received within these periods is lost. We call these intervals blind times. B. Buffering capacitors versus network relay and publish retirement missions parameters. Apart from the AKI, actual implementations may include other buffers used, for example, to store the packets before they can be transmitted at the physical interface. These buffers, depending on the size, may introduce additional issues. For example, increased delay versus unraised discharging of messages. This will be discussed in the following paragraph. A priori mesh implementation compatible with the core BLE 4.2 manage only one buffer of event at the link layer. However, from version 5.0, several events set can be managed and interleaved. The absence of details in the specification limits the definition of general framework, consequently in the number of managed buffers in mesh implementation. Yet, based on experiment evaluation of real chipsets, we have identified at least two separated buffer set relay nodes that also act as source or destination nodes. One buffer for storing relayed PDUs and one for storing network PDU organization in the node. C. Network relay and public transmissions parameters. Network relay and public's reputation impact directly on the reliability of network because they provide diversity against possible errors or collisions over the different links. However, high values in the number of representations and time intervals between repetitions produce increased delays, networks saturation, and a significant reduction of throughput depending on the scenario. Related to the increased delays, even if no concurrent message transmission occur in the mesh network between several source and destination nodes, the major impact concerned to network and relay parameter configuration. Nevertheless, it depends on the link or physical level BLE core specification. When BLE version 4.2 is considered, mesh specification is defined compatible with specification. The link layer manages advertised event sequentially. This means that if a source transmitted managed access PDU sequence against PDF as affected by reputation the process of the previous ones. Wherever it network transmit code and it relay transmit from configuration being N and NTIS, the network transmit count and interface steps. Thank you.